This week on the show, we have FreeBSD ULE versus Linux CFS schedulers battling, OpenBSD on Tuxedo InfinityBook, how Zfs Diff actually reports file names so efficiently, why choose FreeBSD over Linux, PS4 double free exploits, OpenBSD's Wi-Fi autojoin, and FreeBSD jails the hard way in this week's episode of BSD Now. BSD Now, episode 2, to the power of 8, because computers. Recorded for the 25th of July, 2018. Hello, I'm your host, Benedikt Reuschling.
And I'm Alan Jude.
And welcome to this special episode, not just because of the length, but we also want to celebrate a little bit our little 256th episode here. We've come a long way, and we thought we would give our listeners and occasional just show notes readers something to celebrate this special occasion. So we thought, what should we do? So I still have a spare Mojix power bagel. For those of you who don't know what this is, it's a travel power adapter where you don't have to spend too much time thinking of what kind of adapter do I need for that specific country. You just plug it in and you share it with a couple of friends because it's a radial layout. You can see that on the back here, maybe. So they won't block each other. This is how it looks from the bottom, not too exciting. So you always have power and you can share it with a couple of people, for example, at a conference.
Yeah, so like, if you see the picture here, you can see, oh look, this bastard with his Mac adapter is taking up the whole power strip. But if it was a power bagel, look, you can plug in 3 Macs and no problem.
Yeah, so you can get one of those. It's, I think, the white one. I haven't looked inside it. It's still sealed, and I won't open it until we ship it to you. How could you get your hands on this little thing? It's only one, unfortunately, but the lucky winner would have to do the following. Go back to find the 4 episode in December of 2017. In those, I have some letters in my bookcase over here, roughly around here. Find those letters in those 4 episodes, and each episode they spell a different word. And you can send us this word in order. So the first episode has this word, second episode that one, and so on, to feedback@bsdnow.tv with a subject line, BSD Now 256, so that we find it in the flood of emails that we are going to get each time, until August 8th, 2018, 1800 UTC. That's our regular show recording time. And then from the number of people who send us these emails, we'll randomly draw the winner on the live show. So you can definitely see that we are not cheating in any way. And then we'll contact you offline to ship this little item to you. And then you have it. Only one item, again, all decisions are final. Better luck next time if you lose. That's the legalese. So again, find the 4 letters in the December episodes of 2017, which words they spell, send that to feedback@bsdnow.tv so we get 4 letters from you, or no, not 4 letters, 4 words, and use the subject line BSD Now 256, send it to feedback@bsdnow.tv until August 8th, 2018, 1800 UTC. Okay, enough celebrations. Of course, you can always send us stuff on our little Twitter account. Use the hashtag BSDNow256, but don't use that for entering that little raffle here. So, back to the actual show. We have headlines as every week. Every 256th episode had that, and we're not going to stop that. It starts with Battle of the Schedulers, FreeBSD ULE versus Linux CFS. This is a PDF here.
So this is a paper from the 2018 Usenix Annual Technical Conference, which was in Boston from July 11th to the 13th, so just very recent here. And they basically ported the FreeBSD scheduler over to Linux, and then compared the Linux native scheduler with the port of the FreeBSD scheduler. This paper analyzes the impact of application performance, the impact on application performance of the default design and implementation choices made by the two widely used open source schedulers, ULE, the default FreeBSD scheduler, and CFS, the default Linux scheduler. They say we compare ULE and CFS to otherwise identical or in otherwise identical circumstances. We've ported ULE from FreeBSD to Linux and use it to schedule all threads that are normally scheduled by the CFS scheduler. We compare the performance on a large suite of applications on the modified kernel running ULE and on the standard Linux kernel running CFS. I think this was Linux kernel 4.9 when they were testing this. Mm-hmm. The observed performance differences are solely the result of scheduling decisions and do not reflect differences in other subsystems between FreeBSD and Linux. Again, they ported the FreeBSD scheduler to Linux to make the test more the same. Because if they compared FreeBSD and Linux more directly, other subsystem performances like the storage subsystem could impact the results. So by changing only the scheduler, they have fewer variables and we have more likely useful results. Mm-hmm. And their conclusion, there is no overall winner. On many workloads, the two schedulers perform very similarly, but for some workloads, there are significant and even surprising differences. ULE may cause starvation, even when executing a single application with identical threads. But this starvation may actually lead to better application performance for some of those workloads.
Oh, because that one application pretty much runs till the end?
And right, but that one application has multiple threads, and having the threads compete with each other might actually cause enough cache thrashing stuff to make performance worse than actually letting them take turns starving each other.
Okay, yeah.
There's more detail in the paper. The paper's quite long, and obviously we can't cover it all.
Of course.
They say the more complex load balancing mechanisms used in the Linux scheduler, CFS, react more quickly to workload changes, but ULE achieves better performance balancing in the long run. Okay. The operating system kernel schedulers are responsible for maintaining high utilization of hardware resources, keeping the CPU cores busy, using memory and I/O, and so on, while providing fast response times to latency-sensitive applications. They have to react to workload changes and handle large numbers of cores and threads with minimal overhead. This paper provides a comparison between the default schedulers of two of the most widely used and deployed open source operating systems, the completely fair scheduler called CFS on Linux and the ULE scheduler used in FreeBSD. And their goal is not to declare an overall winner, but just to analyze the results.
Yep, sounds fair.
I say, in fact, we find that some workloads ULE is better, and for others, the CFS is better. Instead, our goal is to illustrate how differences in the design and implementation of the two schedulers are reflected in the application performance under different workloads. ULE and CFS are both designed to schedule large numbers of threads on a multi-core system. Scalability considerations have led both schedulers to adopt per-core run queues. So each core has a list of the processes that are wanting time on the CPU, and the priorities and so on decide how far up that list you are, and then it runs the thing on the top for a while. But eventually, to avoid starvation, it will decide, all right, the person at the front of the lines had enough, put them back at the front of the line and take the second person temporarily or whatever, or send them back to the back of the line or whatever. Sure. On a context switch, a core accesses only its local run queue to find the next thread to run. Periodically and at selected times, like when a thread wakes up, both ULE and CFS perform load balancing, that is, trying to move, it's kind of like at the grocery store. If you're in the long line for a till and another one opens up or is draining much quicker, you might change lines. So the kernel goes through and rebalances those run queues, so you don't end up with one with a really big line and one where the CPU is not doing as much work as it could be doing.
Won't you come over here?
Yeah. But at the same time, scheduling on, say, a hyperthread of the same core, if you're going to switching to one that's nearby may give you less of a performance penalty for the move. Because basically at the same time, moving back and forth between lines can actually end up with you never getting to the front of the line or otherwise suffering, the cache on the CPU won't have your data in it, and you could end up making your performance worse rather than better. So ULE and CFS, however, greatly differ in the design and implementation choices. For example, the FreeBSD ULE scheduler is 2,950 lines of code, so about 3,000 in FreeBSD 11.1, which is the version they were doing the comparison on, while Linux's CFS is more complex at just shy of 18,000 lines of code.
Ew, that's a difference.
And that's using the latest LTS Linux kernel 4.9. FreeBSD run queues are first in, first out. For load balancing, FreeBSD strives to even out the number of threads per core. In Linux, a core decides which thread to run next based on the prior execution time, the priority, and the perceived cache behavior of the threads in the run queue. Instead of evening out the number of threads per core, Linux strives to even out the average amount of pending work. So Linux is keeping track of how long did that thread need the CPU last time, assuming it will need the same amount of CPU next time, and tries to aim to have all of those run queues be emptied at the same time. Whereas FreeBSD is aiming to just keep the same number of items waiting in line for each one, right? And again, the grocery store analogy, there is the express line for people with 10 items or less. And while that line may be longer, it's probably going to get you checked out quicker. But at the same time, again, hyper optimizing isn't always that worthwhile.
Sure. Different approaches.
Yep. So they talk a bit about the machine they used and how they were configured. It was an AMD Opteron 6172 with 32 gigs of RAM. They also ran the experiments on a smaller desktop machine with an 8-core Intel i7-3770. And they found about the same results, so that they don't think the CPU had much difference in the performance or in the results of their testing. And they have lots of details in here, but they look at some of the performance analysis, like the periodic load balancing, where the threads get put, and so on. And they have nice, fancy, colorful graphs. But into the performance analysis, they say, we now analyze the impact of the per-core scheduling on the performance of 37 applications that they selected. We define performance as follows. For database workloads and NAS applications, we compare the number of operations per second. And for the other applications, we compare, one, the execution time. I don't know why there's a 1/ in there. Sorry. So they compare execution time, how long it took to actually finish the work. The higher the performance, the better a scheduler has performed. And figure 5 represents the performance difference between CFS and ULE on a single core, with percentages above 0, meaning that the application execute faster on ULE than CFS.
Okay.
So here's the line. If the line is above 0, it means UFS or ULE was better. And if it's below the line, these 4 major cases here, then it was faster on the Linux
CFS.
Yeah.
Completely fed scheduler.
That's not figure 5. Sorry. Wrong graph. That's the multi-core version. Here's a single core one. Here's single core. So in single core, ULE is faster, very much faster in this one case, whereas CFS is much faster in this case. And otherwise, they're pretty even, although there's a couple of individual cases where one is better than the other. But they're pretty close. Overall, and then the figure 8 down here, one shows the same thing, but on a multi-core system. And we see that there's no case where the Linux scheduler has a much bigger performance boost in the multi-core scenario. Overall, the scheduler has little influence on most workloads. Indeed, most applications use threads that all perform the same work. So either doing the more complicated thing like the Linux does, where it tries to guess how long the thread's going to need to do its work. If all the threads are doing the same amount of work, then that optimization doesn't do anything for you. So both CFS and ULE end up scheduling all of the threads in a round-robin fashion. The average performance difference between the two schedulers is 1.5%. And that's usually in favor of the simpler ULE because you're executing fewer instructions to decide how to schedule the work likely. But the SciMark benchmark is 36% slower on ULE than CFS, whereas the Apache Bench test they did was 40% faster on ULE than on Linux. SciMark is a single-threaded Java application. It launches one compute thread, and then the Java runtime executes other Java system threads in the background, like garbage collection, I/O, etc. When the application is executing with ULE, the compute thread can be delayed because Java system threads are considered interactive and get priority over that computation thread. So on FreeBSD, the scheduler is trying to make sure that the one CPU, the compute thread, is trying to use all the CPU, doesn't hog the whole system and make sure that the background tasks still happen. But by treating those background tasks as interactive, it can end up giving them more priority than they probably should have had, and it results in worse performance. Whereas the garbage collection is supposed to happen off in the background and get out of the way.
Yeah,
And the Apache workload consists of two applications. One, the main server, the HTTPD running 100 threads, and then AB, Apache Bench, running a single-threaded load injector. The performance difference between ULE and CFS is explained by different choices regarding thread preemption. So when you get kicked off the CPU to let other people have a turn. In ULE, full preemption is disabled, while in CFS, preempts the running thread when the thread that has just been woken up has a vRuntime that is much smaller than the vRuntime of the currently executing thread. 1 millisecond difference in practice. So if you've had more time than the other person, then they get to go in front of you. Right? It's completely fair. It's like
everyone gets a fair
definition
share.
of fair. It's not necessarily right, but everybody gets the same amount. It's like you've been on the CPU for a minute, and this kid's only been on it for 59 seconds. They get a turn now.
Yeah. Hand over the CPU, yield it, hand it over.
In CFS, Apache Bench is preempted 2 million times during the benchmark, whereas in ULE, it's never preempted because there's no preemption set. This behavior is explained as follows. AB starts by sending 100 requests to the HTTP server, and then it waits for the server to answer. When AB is woken up, telling it that there's an answer, it checks which requests have been processed and then sends that many new requests to the server to keep the number of outstanding requests always at 100. Since AB is single-threaded, all requests sent to the server are sent sequentially. In ULE, AB is able to send as many new requests as it has received responses before it goes back to sleep. In CFS, every request that AB sends wakes up the HTTPD thread, which has spent less time on the CPU than Apache Bench. So Apache Bench, as soon as it sends one request, gets sent to the back of the line and let the request get processed, and that results in much less performance. I know it wasn't the point of the test, but if you were just testing HTTP server performance, you probably want to run the Apache Bench on a different machine. But because, in particular, they're trying to measure the scheduler, running them on the same machine, the result of this doesn't mean that FreeBSD is 40% faster at running a web server than Linux is.
Yeah, there are other variables.
I don't know, but it just means that in this case, the decisions made by the FreeBSD scheduler for this mix of workloads has the best results.
Yeah,
and again, these tests are mostly an individual workload running by itself. So this is just the application competing with itself, not what happens when you have two applications trying to fight over the CPU or so on.
Mm-hmm.
It'd be interesting to see
in high load situations
kind of run again, but with one multi-threaded CPU hogging process running and see how that's, I wonder if you could make an evil application that acts like a web browser and see how it impacts the performance of every other application on the machine.
Yeah, for the benchmark.
Yeah,
that would be interesting to see how the outcome is.
Yep. So in their conclusion, scheduling threads on a multi-core machine is hard. In this paper, we performed a fair comparison of the design choices of two widely used schedulers, ULE scheduler from FreeBSD and the completely fair scheduler from Linux. We show that they behave differently even on very simple workloads, and that no scheduler performs better than the other on all workloads.
Okay. That's good.
On average across their benchmarks, ULE was better by 1.5%, but depending on the workload, sometimes the CFS scheduler was better.
And the scheduler doesn't know what kind of workload it's going to get. Is it desktop workload? Yeah. Is it server workload? What kind of applications will be needed to be scheduled? Yeah, and that's difficult to have a uniform scheduler that is good at every of these workloads. But yeah, it's a good paper, and there's of course even more detail that we could cover in this show. But check out the PDF. We'll have it in our show notes. So next up is OpenBSD 6.3 on Tuxedo InfinityBook. That's over at hazardous.org, and they have a blog there, of course, with a disclaimer at the beginning stating that they came across the Tuxedo Computers InfinityBook last year at the Open Conference, which is a German conference, by the way, I figured out, where Tuxedo had a small booth. Previously, they came to their attention since they are a member of the OSB Alliance, and on whose board they are a member of. I don't know who the author of that book of that blog is, but let's leave it at that. Furthermore, Tuxedo Computers are a sponsor of the OS Bar, which I'm part of the organizational team. So that starts with, after the disclaimer, it goes, I've asked the guys over at Tuxedo Computers whether they would be interested to have some tests with BSDs done, and that would test drive one of their machines and give feedback on what works and what does not work, and possibly look into it. That's a good idea. Within a few weeks, they shipped me a machine, and last week the InfinityBook Pro 14-inch arrived. Awesome. That's already thanks already to the folks at Tuxedo Computers. The machine arrived accompanied by lots of swag even. Oh, wow. They seem to like these sorts of things. Okay, so the InfinityBook is a very nice machine and allows a wide range of configuration. The configuration that was shipped to me was Intel Core i7-8850U, 116 gig RAM, Crucial Ballistics Sport LT, and a 250 gigabyte Samsung 860 EVO. Oh, that's not an old model. That's pretty decent. M2 SATA.
M2 SATA NVMe.
So they used USB sticks to boot and install OpenBSD 6.3 and reinstalled the machine with OpenBSD, of course. The full DMESC is linked there. The installation went flawlessly. They needed Intel firmware being installed after installation automatically with FW update. And out of the box, the graphics worked, and once installed, the machine presented a login. So here's a little video, and you see some extracts from the DMESC. So when X starts, the display is turned off for some reason. You will need to hit function key F12, or the modifier key, the key with the moon on it, that's the one for brightness usually, and then the display will go on. Aside from that little nit, X works just fine and presents one of the expected resolutions. So you can see a couple of terminals here and a browser, of course, with the OpenBSD website. And external videos working just fine. They write as well. Either via HDMI output or via the mini DisplayPort connector. Oh, nice. The buttons for adjusting the brightness are not working. Instead, one has to use the WS control to adjust the brightness. So they can do as WS control display the brightness, and then you can set it to the percentage you would like. Networking. The InfinityBook has built-in Ethernet driven by the RE driver. So you can see the RTL link here, Realtek. And for the wireless interface, the IWM driver is being used. So that's not too much of a new thing here, but good that there's support. Both work as expected. ACPI, yes, neither suspend nor hibernate work. Oh, that's bad. Reporting of battery status is bogus as well. Some of the keyboard function keys work though. LCD on and off works, keyboard backlight dimming works, and volume works. Well, if I had a choice, I would I would have rather liked suspend and resume. But yeah, maybe they will get the feedback and work on that. So sound, the Azalea chipset is being used for audio processing. So that's giving you a little bit into your ears if you play something that's audio, and works as expected. Volume, the buttons Fn plus F5 plus Fn plus X6 or mixer CTL control the audio. Touchpad, Synaptics touchpad found, not too exciting, can be controlled via WS control, and so far they write, they must say that the InfinityBook makes a nice machine and they're enjoying it. Yeah. Cool. And it's nice that they gave them some machine to test it on. Would be interesting to see the other BSDs on that.
Yes, that was my first thought is I wonder how FreeBSD works, and also if the suspend problem is hardware specific, a BIOS setting that's in the way, or if it's, if it might work on FreeBSD. For suspend not working, try in the BIOS disabling the TPM, the Trusted Platform Module or whatever. That's what was blocking suspend and resume working on some machines under FreeBSD. And just disabling that unused feature in the BIOS got suspend and resume working on a bunch of models of laptops for FreeBSD. And maybe that will solve the problem with this Tuxedo InfinityBook.
Yep. And they gave me a new conference to look for in the future. Maybe that's something I will submit something to. But yeah, that's a German one, so I will put it on the list. Speaking of a list.
Well, yes. If you are buying a server and you don't want to have the same questions that somebody with buying a laptop does of, is the disk controller going to be supported? Am I going to have problems with installing NVMe devices in it, or
RAID controllers, all these kinds of things.
Then you should call up IX Systems. Head over to ixsystems.com/BSD Now and check out their guide for how enterprise storage is disrupting the market. In
a good way.
Yep. You can see how your storage should be backed by open source. And if you're going to build a server, you want it one built by a company that actually understands open source and understands BSD. So call up IX Systems, tell them what you want to do with the machine, and they will help you design the best BSD server.
Yeah, for example, do you need more memory or more CPU horsepowers for that specific application? Or are you really in need of a big storage system that just does all the data storage? And that should also be expandable, because the more data you store, and you never delete probably, you might need to have more disks in the future. And they can also not only send you the disks, of course, but also think about, you might need X more disks in that shelf. So we size it up a little bit further, because in a year or so, you might call us again and want to have more space.
Yeah, well, in particular, they also understand ZFS better than most other vendors. And so in particular, a common mistake people make is decide that they're going to put terabytes and terabytes of read cache in their ZFS array. So they buy a bunch of these really expensive, really large SSDs, possibly not high enough endurance to actually be useful as a cache, and stick them in a ZFS machine. The problem is, for this L2 ARC, the read cache in ZFS to work, it needs memory. So ZFS has a cache called the ARC, right? The adaptive replacement cache. And in it, you cache a header and the data. And so some amount of your memory is used to cache the most recently used and most frequently used data from your pool, so that when you need it again, you don't have to go out to disk. Then, when that cache gets full, blocks that are about to fall off get paged out to the level 2 cache, the L2 ARC, which is the read cache, which is usually fast SSDs or NVMe. Problem is there, in order for ZFS to know that that data is on that SSD and that it could go get it from there instead of getting it from the disks, it still needs the header in memory. So it's a smaller data object, right? You're not, if it's a 128K block of data, then in memory, you would take that 128K plus the header. Having just the header doesn't take as much memory, but you still need some memory for every single block that's in the read cache. Well, if you have terabytes and terabytes of read cache for, say, a machine running a database server or like hosting VMs with a lot of 4K block iSCSI volumes or NFS volumes or whatever, you're going to end up using all of your memory for the level 2 cache and miss out on the level 1 cache that's even faster. So they help prevent you making mistakes like that, like putting way too much level 2 storage with not enough level 1 to actually sometimes even be able to use all that level 2. It's physically impossible to have that much data on the L2 arcs because you don't have enough RAM to just store the pointers to it. And you probably need some RAM for everything else happening in your system, and ZFS is a lot faster if you let it cache the stuff that's really important in RAM, because no matter how fast your NVMe is, your RAM is still faster.
Yep. And it's compressed memory, so you can fit much more data in it than you would have in a different file system.
Yes, but the headers still take the header amount of room, right? You can't really compress that.
Sure, yeah, that's a given.
They're small, but you're talking about millions or billions of blocks in your system. Each one's going to need a header.
Yeah, otherwise there's no knowing where this file is belonging to.
If you have terabytes of storage and they're all broken down into 4 kilobyte blocks, that's a lot of blocks.
Mm-hmm.
Anyway, head over to ixsystems.com/BSD Now, get in touch with them, tell them we sent you, and they'll be extra nice to you.
Don't forget to check out the blogs as well. They have interesting articles there from the storage space. And this one has an interesting NAS article about whether we think that is still...
NAS used to mean the cheaper solution as opposed to a SAN. But now, Ethernet is so fast, almost all storage is NAS storage, not SAN storage. Some other places still try to sell it to you as SAN storage because SANs cost more money than NASs, right? But anyway,
it's not so simple anymore.
You should definitely read this.
Yep. But on with the show. We have...
Speaking of ZFS.
Speaking of ZFS, actually, yeah. How ZFS makes things like Zfs Diff report file names efficiently is our next item here.
Yeah, so this is building on the stuff we talked about last week about the way block pointers work. Mm-hmm. And remember, we talked a little bit about how everything in ZFS is actually objects, and they just have numbers, and that's how it looks everything up. So when you want to do Zfs Diff, which allows you to compare 2 snapshots to each other, or a snapshot in the live system, and see which files and directories have been changed, added, removed, etc. And it's very useful for being able to tell when something has been changed or which things have been changed between snapshots. So they say, as a copy on write file system, ZFS can use the transaction group numbers that are embedded in the ZFS block pointers to efficiently find the differences between any 2 transactions. And this is used, for example, with ZFS bookmarks and snapshots. And that's how incremental replication works, and why ZFS is so much faster at incremental replication than something like rsync.
Oh, yeah.
Because rsync has to walk the whole file system and check each file. Are you newer? Are you newer? Are you newer?
Whereas
ZFS just knows this range of blocks have a birth time between the starting point and the ending point of our replication. So I just copy all of those in bulk, and I don't have to know which file they belong to or any of that. Just all this data, ship it, and when applied to the other end, you will have the file system as it existed at the endpoint. Anyway, as he said, however, as I noted at the end of his entry on block pointers, this doesn't give us file system level differences. Instead, it essentially gives us a list of inodes, or in ZFS they're called dnodes, that have changed. So you have, when you run the first pass of ZFS Diff, you can just look at the transaction group of the first comparison item and then the second comparison item. And every block with a birth time greater than the first one and up to equal to the second one is something that has changed. So that gives you a list of every block that has changed. But that's not very helpful. What people want to know is which files have changed. And backtracking that could be a really expensive operation under most file systems. Like, especially with hard links and stuff. Like, if you know the inode of something on UFS, you can easily look up the data. But if you want to know what file names it might have, you basically have to do a find across the whole file system for any file with that inode number.
That could take some time, yeah.
Yeah. So, in theory, turning an inode or dnode number into a path in a file is an expensive operation. You basically have to search the entire file system until you find it. In practice, if you've ever run Zfs Diff, you'll likely notice that it's pretty fast. This is the only place that ZFS quickly turns dnode numbers into full path names as it comes up. This is not the only place where ZFS needs to do it quickly. You'll also notice zpool status. If there are any damaged blocks, you get the file name of those blocks. And it doesn't take a long time to do.
So restore those from backups.
At one level, ZFS Diff and zpool status do this so rapidly because they ask the ZFS code in the kernel to do it for them rather than doing it via userland. At another level, the question is how the ZFS kernel code can do it so quickly. So the interesting and surprising answer is that ZFS cheats in a way that makes things very fast when it works, and almost always works on normal file systems and with normal usage patterns. The cheat is that ZFS dnodes record their parent object number. So if you use ZDB, the ZFS debugger, you can see here we're going to look at a specific block. So ZDB triple verbose quadruple block. And we tell it which data set and which path in that data set. And it gives us the object number, what level it is, the indirect block size, the actual block size, size, dnode size, logical size, etc. And we see that this is a plain file, the file, temp/a/b, and at its parent object is 1284472. So then, when we do the same thing and we look at the parent directory of the file B, which is a directory called A, we see that same object number and that its parent is 52906, and that it contains what's called a microzap, which we talked a bit about when there was the ZFS on Linux bug that was causing files to disappear. So the zap is basically a little key value pair, and it says that if you look at the directory A, it has a key value pair where the key, the file name B, is an object number that points. So the directory has a list of all the files in the directory. The B file has a parent field that points to the directory that it's in. And the A directory has a parent object that points to its parent, and so on. When the kernel wants to get the name of a given object number, it just fetches that object, looks at its parent, so going up one level, and then that parent will have a key value pair list of name to object number. So when you know the object number and you want to know the name, you look up the object, you find its parent, you go to the parent, and that parent will have a list of the mapping of the name to the object number for you. And so it's actually a pretty straightforward search.
Yeah, that's the cheating part.
Yeah. If you want to see the sausage being made, you can look at the ZFS object to path and ZFS object to p object for parent object in ZFS_znode.c. The parent field in the ZFS dnode system attributes is ZPL_parent. If you're familiar with the twists and turns of Unix file systems, you're now wondering how ZFS deals with hard links, where there might be multiple file names that point to the same object number or the same data on disk, which can cause a file to have several different to be in several different directories at once and to have several different parents. And then it has, and then some of those could have been removed in the meantime. The answer is that ZFS doesn't. A dnode only ever tracks a single parent. the ZFS and ZFS accepts that this parent information could be inaccurate. I'll quote a comment from the ZFS object to parent object function. When a link is removed, the file's parent pointer is not changed and will be invalid. There are two cases where a link is removed but the file stays around, when it goes to the delete queue and when there are additional links. Before I get into the detail, I want to say that I appreciate the brute force elegance of this cheat. The practical reality is that most Unix files today don't have extra hard links, and when they do, most hard links are done in a way that doesn't break ZFS's parent stuff. The result is that ZFS has picked an efficient implementation that works almost all of the time. In my opinion, the great benefit we get from having it around is more than worth the infrequent cases where it fails or malfunctions. Both Zfs Diff and having file names show up in zpool status for permanent errors are very useful, and there are other cases where this is used as well. The current details are that anytime you hard link a file or to somewhere, so if you hard link a file to somewhere, or if you rename it, ZFS updates the file's parent to point to the new directory. Often, this will wind up with the correct parent even after all the dust settles. For example, a common pattern is to write a file to an initial location, hard link it to its final destination, then remove the initial location version. In this case, the parent will be correct, and you'll get the right name for it. The time when you get an incorrect parent is if you do the sequence create directories A and B, touch A/demo, link A/demo into B, so now you have B/demo, and then remove B/demo, leaving the original version. In this case, A/demo will be the remaining path, but demo's D node will claim that its parent is B. I believe that ZFS Diff will even report this as the path, because the kernel doesn't do the extra work to scan the B directory to verify that demo is actually present there. He says this behavior is undocumented and thus is subject to change at the convenience of the ZFS people.
Okay, interesting how they did all these little things and thought about that. Like, how did file systems do it in the 90s, and how let's do it on ZFS in better way.
The parent isn't really used for much except for this going backwards idea. So when you go into the A directory, you will see, hey, in its zap, there will be a link that says demo is this object number. So the file will still be there. It's just that if you look up the object number and want to go back to the directory name, it'll point to one that maybe has been removed. But yeah, that's actually fine. It makes more sense than when you delete a hard link, ZFS having to go through and scan every object and try to find, or scan every directory and see if that object is in it and update its parent or something. Or having the parent have to be some extensible data structure where it's an array of all the possible parents or something. It just doesn't make sense. And, works 99% of the time as far as quickly being able to do this is worth it. Worst case, you could fall back to the old-fashioned UFS way of doing a /find or doing a find across the entire file system and looking for that object number.
Yeah, where is it? Number. And it also shows that ZDB is always this mysterious thing that only the ZFS developers should use. But now with that kind of explanation, people can make use of that and see, oh, this is actually a file or this is a directory, and how to find these entries.
What's interesting there is I've never used ZDB exactly that way. I usually use the -D switch, not -B. So I'm going to have to look at some files the way they did it and see if it teaches me anything new.
So, time for the news roundup this week. 256 episode, and we've never asked this question. What is FreeBSD? Why should you choose it over Linux? So now we have it in this article over at fosmint.com.
Yep. So they start off, not too long ago, I wondered if and in what situations FreeBSD could be faster than Linux, and we received a good amount of informative feedback. So far, Linux rules the desktop space and FreeBSD rules the server space. In the meantime, though, what exactly is FreeBSD, and at what time should you consider it over Linux for an installation? Let's tackle these questions. So FreeBSD is a free and open source derivative of BSD, the Berkeley software distribution, with a focus on speed, stability, security, consistency, and other server features. It has been developed and maintained by a large group of developers ever since its initial release in 1993. As 25th anniversary this year. BSD is a version of the Unix operating system that was developed at the University of California and is being free and open source software. The free as a prefix to BSD is a no-brainer.
Yep, we've all been there.
What is FreeBSD good for? Now that we have the kind of, it's not a great explanation of what FreeBSD is. We do need to write a better one.
It's the short of it.
At one point, Justin was working on an elevator pitch for FreeBSD, and we need to replace that. FreeBSD is a version of BSD, which is a version of Unix, which is from 1970.
Yeah, something quick and easy.
Yeah. So, what is FreeBSD good for? Not
we chuckle here. Yeah.
FreeBSD offers a plethora of advanced features and even boasts some not available in other commercial operating systems. It makes an excellent internet and intranet server thanks to its robust network services and the ability for it to maximize memory usage and work with heavy workloads to deliver and maintain good response times for thousands of simultaneous user processes. FreeBSD runs a huge number of applications with ease. At the moment, there are over 32,000 ported applications and libraries with support for desktop, server, and embedded environments. With that said, let me add that FreeBSD is excellent for working with advanced embedded platforms like ARM and MIPS. So whether that's mail or web servers, time servers, routers, or MIPS hardware or whatever. FreeBSD is available to install in several different ways. You can get CD, DVD, or memstick images, or you can do the install over NFS or FTP and so on. And FreeBSD is easy to contribute to, and all you have to do is locate the section of the FreeBSD code, modify it, and send in a patch. Potential contributors are also free to improve on its artwork and documentation, along with any other aspect of the project. FreeBSD is also backed by a nonprofit organization that can contribute to financially, directly, and it's tax deductible in the US.
Yep, that's also a benefit if you're donating.
And one of the big things is FreeBSD's license allows users to incorporate the use of proprietary software, which is ideal for companies interested in generating revenue. For example, Netflix cites as one of the reasons that they chose to use FreeBSD servers. Although most of the changes Netflix has made are put back into FreeBSD open source. And I think the main reason they chose FreeBSD was how the level of ease it was for them to incorporate their changes back upstream and not have to worry about the fighting over licensing or just, the difficulty you can have in getting code into upstream Linux. But now to the important question, why should you ever choose FreeBSD over Linux? From what I've gathered from both FreeBSD and Linux, FreeBSD has a better performance for a lot of server type workloads, like storage. And its packaged applications are configured to offer more options and better performance than Linux, and it's usually running fewer services by default, which means more of the computer is left for your workloads. FreeBSD is reportedly more secure than Linux because the whole project is developed and maintained together instead of a bunch of constituent parts that are put together at the end. So everything is more integrated. And unlike Linux, the FreeBSD project is controlled by a large community of developers. There are almost 400 FreeBSD committers, and then they elect a core team of 9 people to serve a term of 2 years and kind of steer the project. Whereas under Linux, there's Linus, who controls everything, and then he has some lieutenants that he gives some power to, but the total number of people with the ability to write code into the Linux Git repo is small enough you can count them on one hand.
And there are no elections at all.
Yeah. They also say FreeBSD is much easier to learn and use because there aren't 1,001 distros to choose from, and most of the things that make distros unique on Linux are just packages on FreeBSD. FreeBSD is more convenient to contribute to because it's an entire OS. So if you want to change stuff, you can change the kernel side and the userland side in one repo rather than having to get your contribution coordinated between 4 different projects to make the change actually usable in the operating system. Apart from all the documentation and guides you can find online, FreeBSD also has the handbook, which is a kind of a central source of information on pretty much everything in the OS.
Yeah, for people who want to dig a little bit deeper.
And because FreeBSD has the ports system, in addition to augment packages, you can custom compile your software easily and get whatever options you want, where that's usually pretty difficult to do on Linux. And it helps solve some of the dependency and version tracking issues because you can build an application to use the versions of software you already have rather than having to try to, upgrade everything in lockstep to make them all match. They say, while both the FreeBSD and Linux projects are always receiving updates, the platform you decide to go with is largely dependent on what you want to use it for, your technical know-how, and your willingness to learn new stuff, and ultimately your personal preference. So you should give FreeBSD a try, and maybe you'll like it.
Yeah, that's a good way to spend some time. Of course, you could spend your time playing with the PlayStation 4, which also internally runs FreeBSD. But this article we have next is a PlayStation 4 505 BPF double-free kernel exploit write-up. So that starts with, similar to 4.55, the kernel exploit here. This bug actually is interesting primarily to exploitation on the PlayStation 4, but it can also be used on other systems using the Berkeley packet filter and the virtual machine there if the attacker has sufficient permissions. So it's been published under the FreeBSD folder. So there's a couple of exploits there. If you found any mistakes and suggestions, of course, and you can find that in GitHub and send it to them. So, but introductory thing to that one is welcome to the 5.x kernel exploit write-up. A few months ago, a kernel vulnerability was discovered by QWERTY. Run over the keyboard with your left hand, or the right one if you like. And an exploit was released for BPF which involved crafting an out-of-bounds write via use after free due to the lack of proper locking. It was a fun bug and a very trivial exploit. Sony then removed the write functionality from BPF, the Berkeley packet filter, so that exploit was patched. However, the core issue still remained, being the lack of locking, and a very similar race condition still exists in BPF past 4.55, which we will go into detail below. The full source of the exploit can be found also on the GitHub page. It's a link there. So this bug is no longer accessible, however, past 5.05 firmware because the BPF driver was finally been blocked from unprivileged processes. WebKit can no longer open it. Sony also introduced a new security mitigation in 5.0x firmwares to prevent the stack pointer from pointing into user space. However, we'll go into more detail as this unfolds further down. And the assumptions there are made of the reader's knowledge for the write-up. And of course, a little bit of understanding of C, x86, and exploitation basics is also helpful, though not necessarily required. So a backup thing, background, not backup. Well, backups are always good. Background here. This section contains some helpful information to those newer to exploitation or are unfamiliar with device drivers or various exploit techniques such as heap spraying and race conditions. So feel free to skip to the A Tale of Two Free section if you're already familiar with this material. So that's further down. So it starts off with what are drivers. There are a few ways that applications can directly communicate with the operating system, one of which is system calls. There are over 600 of them in the PS4 kernel. Roughly 500 of them are FreeBSD ones. The rest are Sony implemented. So another method is throwing something called device drivers. Those drivers are typically used to bridge the gap between software and hardware devices, USB keyboards, mice, other drives, webcams, for example, though they can also be used just for software purposes. There are a few operations that a userland applications can perform on a driver, if it has permissions for that, to interface with it after opening it. In some circumstances or instances, one can read from it, write to it, or in some other cases, issue more complex commands to it via the ioctl system calls. The handlers for these commands are implemented in kernel space. This is important because any bugs that could be exploited in an ioctl handler can be used as a privilege escalation straight to ring 0, typically the most privileged state. Drivers are often the more weaker points of an operating system for attackers because sometimes these drivers are written by developers who don't understand how the kernel works, or the drivers are older and thus not wise to newer attack methods. So the BPF driver in general, if we take a closer look around inside the WebKit sandbox, we'll find a /dev directory. With this may seem like the root device driver path, it's a lie. Many of the drivers that the PlayStation 4 has are not exposed to this directory, but rather only ones that are needed for WebKit's operation, for the most part. For some reason, though, BPF, the Berkeley Packet Filter device, is not only exposed to WebKit's sandbox, it also has the privileges to open a device as read and write. This is very old and odd because on most systems, this driver is root only, and for good reasons. If you want to read more into this, they have a different write-up in their 4.55 FW. So what are packet filters is the next section. So below is an excerpt from the 4.55 BPF write-up. Since the bug is directly in the filter system, it is important to know the basics of what packet filters are. Filters are essentially sets of pseudo instructions that are parsed by BPF filter, that function, which are ran where packets are received. So each time a package comes in, they will call this function. While the pseudo interface instruction sets are fairly minimal, it allows you to do things like perform basic arithmetic operations and copy values around inside its buffer. Breaking down the BPF virtual machine in its entirety is far beyond the scope of this write-up, they write. Just know that the code produced by it ran in kernel mode. This is why read and write access to dev BPF should be privileges. Yeah, and not everyone should be allowed to poke around with that. And next item is what are race conditions? So that one goes. Race conditions occur when two processes or threads try to access a shared resource at the same time without mutual exclusion. You might have heard of that. The problem was ultimately solved by introducing concepts such as the mutex or log. The idea is when one thread process tries to access a resource, it will first acquire a log, access it, then unlock it once it's finished. If another thread or process tries to access it while the other one has the log, it will wait until the other thread is finished. This works fairly well when it's used properly. Locking is hard to get right, especially when you try to implement fine-grained locking for performance. One single instruction or line of code outside the locking window could introduce a race condition. Not all race conditions are exploitable, but some are, such as this one, and they can give also an attacker very powerful bugs to work with. So that leaps into heap spraying. The process of heap spraying is fairly simple. Allocate a bunch of memory and fill it with controlled data in a loop and pray your allocation doesn't get stolen from underneath you. It's a very useful technique when exploiting something such as a use after free method, or as you can see it, to get controlled data into your target object's backing memory. And by extension, it's useful to do this on a double free as well, because once we have a stale reference, we can use a heap spray to control that data. Since the object will be marked free, the allocator will eventually provide us with a control over the memory, even though something else is still using it. And that is unless something else has already stolen the pointer from us and corrupts it. Then you likely get a system crash, and that's not fun. This is one factor that adds to the variance of exploits, and typically the smaller the object, the more likely this is to happen. So that leads into the tale of two frees. So the freeze go via the octal command. A user can set a filter program on a given descriptor via commands such as blockio setwf. Do you know that one?
No.
It's a special IO descriptor. Okay, there are other commands to set other filters. However, the write filter is the only one interesting to use for this write-up. An important part of the previous exploit was the power to free an older filter once a new one has been allocated via bpf_setf, which is called directly in that command's handler. This allowed us to free a filter while it was still in use. This free itself is also a bug that can be exploited and is leveraged in the newer exploit. And here's some extract from the bpf_set function, where you can see the code around, and you can see that there's a assignment here. Old equals D points to BD_WF filter, which isn't locked. And that's where the problem is. And there's also a nice illustration here to see what how the locking goes and how the article will exploit those mitigate or exploit those bugs not locked. And then it goes on like corrupting the stack more to actually cause the exploit. And then there's a bigger overview of the whole exploit. And the article is way longer than we could put into in that section, but it's definitely worth a read if you want to know how to especially properly exploit on an older version. Still, the newer filter, the firmware has been patched now, but if you are interested in the packet filter internals and the exploit that are possible in that, then it's a good write-up on this article. And it's illustrated, has code segments, so you should be able to follow along.
Yep. This week's episode of BSD Now is brought to you by DigitalOcean. Head over to digitalocean.com and check it out. If you don't have an account already, if you go to do.co/BSDNow, you'll get taken to a super secret URL that will let you get a $100 credit for this first 60 days to try as many droplets as you can.
Yeah, because they're easy to start. Just takes a couple of seconds. And then you have your nice little virtual machine in the cloud that's internet accessible. So you can do all kinds of things with it, starting with a blog or run a MongoDB database, or you always wanted to try out a certain stack, but you couldn't get it running on your own. You couldn't get it configured. So use the one-click apps that they provide, and they will set it up for you automatically. And you just have to provide your own user accounts. And then you can use a complete like GitLab installation or discourse server or whatever it is. They have a bunch of them available.
Yeah, and all the instances are hourly. So if you only need it for a little bit, you can get a machine with 2 gigs of RAM and 2 CPUs, 60 gigs of SSD back storage, and 3 terabytes of internet bandwidth for 2.2 cents per hour.
Yep. Or
if you want my 2 cents, that's what you should get.
Yeah, it's certainly an interesting combination. If you need more memory, then configure more memory to it. Or if you need a little bit more space, check out their spaces. They have a simple object storage, and that is also interesting to extend your storage.
If you need something kind of more S3-like, or they have block storage. If you want to run Zfs in the cloud, you can set whatever size of storage you need by the gigabyte, and you need 700 gigabytes. It's only $70 a month.
Yeah, and especially for the block storage, it says here $5 per month, 250 gigabyte of storage, 1 terabyte of outbound transfer, and you can try it for free for 2 months already before finally deciding to, I want to have this permanently.
Yep. Also, you can back up your whole droplet. That's what they call their VMs, for 20% the cost of the virtual machine. So if you have the $5 a month droplet, it only costs you $1 a month to have the backup. Or snapshots, if you create a snapshot of your VM, is only 5 cents per gigabyte per month.
It's just great to have a little test machine, and once it's done, the testing is over, then you just discard it and delete it, and it doesn't cost you any more money.
Yep. And if you are using this for a big enough use that you're spending hundreds of dollars a month, you can also get 24/7 tech support and a dedicated account team.
Oh yeah. So that's another way of providing a good customer support. But there's other stuff in the, especially in the networks part. You can say, oh, I have a snapshot transfer that I want to give ownership of that specific snapshot to another DigitalOcean user. And things like that you would normally not get from a off-the-shelf VM provider on the internet.
Yep. So
okay,
head over.
So
if you already have an account, you can use the coupon code FreeBSD Now, all one word, and you'll get a $10 credit that does not expire added to your account. Yep. So our next story is OpenBSD gains Wi-Fi autojoin.
Oh, that sounds exciting.
In a change which is bound to be welcomed widely, OpenBSD-Current has gained the autojoin feature for Wi-Fi networks. Peter Hessler has been working on this for quite some time, and he wrote up about it on his hackathon report. And he's now committed the work at yet another hackathon in Lubyanka. So this introduces the autojoin feature to the 802.11 stack in OpenBSD. This allows a system to remember which ESSIDs it wants to connect to and any relevant security configuration, and switches to it as soon as those networks are available. As soon as the current network is no longer available, it starts scanning the list. So you have a pretty simple configuration in your hostname.if or whatever. You can say join the network called home, and the WPA key is password, or join the network called work.
With some other WPA key.
Yep, and then there's the open lounge, doesn't have a password because it's open Wi-Fi, or the cafe has this password, or I'm going to Japan, so I want to join web network, and the network key is 12345, or whatever.
Or I'm back at BSD CAN.
DHCP on all of them, and the internet's IPv6 autoconf and up, and it's good to go. And the code was reviewed by STSP and Rick Floiter, and enthusiasm was provided by every hackathon I've ever been to in the last 3 years.
Oh yeah, that's certainly true. Yeah, it's certainly a feature people have been looking for.
It says the usage should be clear from the commit message, but basically you add a join line for each of the networks you want to auto-join, as you would previously have used the NWID command to manually connect to. When the kernel, then the kernel will join the network as soon as it is in range and the current network is no longer available. When you move out of range, that network will lose connectivity, and then it will go through the list until it finds one it can join again. Thanks to Peter Hessler for working on this feature, something many Wi-Fi using OpenBSD users will benefit from.
Oh yeah, just these are small things for the user, but it takes some time to implement them correctly. But once you have them, you don't want to miss them again. It's just becoming so normal to have that.
Yes, I remember when WPA Supplicant, the tool that does this on FreeBSD, didn't work for WEP in Japan a couple of years ago, and it was Sean Bruno and I sitting in the hacker lounge trying to get it all working.
Yeah. It's certainly cool to have. Okay. But there's more in our little section here. It's called FreeBSD jails the hard way. Over at the GitHub.io page, I guess. Yeah. DevOps discoveries, FreeBSD jails the hard way. There are many great options for managing FreeBSD jails. IOCage, Warden, and Easy Jail aim to streamline the process and make it quick and easy to get going. But sometimes the tools built right into operating systems are overlooked. So this post goes over what is involved in creating and managing jails using only the tools built into FreeBSD, so nothing from ports to install. For this guide, they will put the jails in user local jails and start with a very simple isolated jail, then go over how to use ZFS snapshots, excellent, and lastly, nullfs mounts to share the FreeBSD-based files with multiple jails. They will also show some examples on how to use the templating power of jail.conf to apply similar settings to all your jails. So first of all, the full jail is to make a directory for the jail or a ZFS data set if you prefer. I do that. So you do the make dir or ZFS create that mount point, and then do your creation of that directory and mount it properly. Then you download the base files of the distribution, which any parts of BSD that you want to like, of course, do you need a kernel for the jail? Probably not, because it's the system kernel they're using. They will include, in this example, the 32-bit libraries for compatibility with 32-bit applications. So they're still using 10.2 release. Of course, you could substitute this with 11.2 release now.
Yep.
Or unless you want to have a very old jail that probably is legacy for some applications or whatever it is, but you can choose. Then you update your base install. So you run FreeBSD update, provide your environment variable, set that to your 10.2 release, which is the one that they should fetch this way.
Basically, it tells FreeBSD update which version you're upgrading from, and then it will fetch all the patches and apply them to your jail.
Of course, verify your download in case it's coming from a source you don't trust. There's the FreeBSD IDS command to verify that installation and the PGPs behind that. And once that checks out, you can make sure your jail has the right time zone and DNS servers and a host name and rc.conf, because these are the settings that every jail needs and should have so that it can work properly on the network and has a proper time.
Yep.
Then you start editing your jail.conf with the details about your jail, like which program or which executable should start it, or how is it stopped, what kind of mounts you want to have, like the devfs file system in there.
Yeah, these ones at the top are the default for all jails, because RC is
Makes
how
sense.
you start up, and RC.shutdown is how you start down, shutdown. And then you have kind of Nginx style block for each jail where you set specific settings like the host name, the path, and the IP addresses.
And once that is done and saved, you can start and log into your jail using jail-c and the name of your jail you just defined in the config file.
Create the jail, full jail 1, and that reads the config file and goes and does it.
Yeah, they write 11 commands and a config file, but this is the most tedious way to make a jail. With a little bit of templating, it can be even easier. So they'll start by making a template, making that as basically the same as steps 1, 2, and 3, but with different destination folder, they'll condense them. So they create a template or a ZFS dataset for it. And when we like to have a ZFS clone method of deploying those templates, we just need to create a ZFS dataset instead of a folder.
Yeah, so they basically do a base install into a dataset called 10.2 release, FreeBSD update it, snapshot it with the patch level, so P10, and then they can just clone that, and now they have a new P10 jail. And then
it's not
they
too
just
difficult.
have the basic 4-line of config here. I want to call a new jail called zjail1. Here's the hostname, path, interface, and IP address. And then I just jail create zjail1, and boom, it's running. If you're short on disk space, which is not very likely anymore, the relative size of FreeBSD install of hundreds of megabytes is not a problem anymore. But if you want, you can have you can do what's called a thin jail, where you actually have one copy of the base system that you reuse on multiple jails. The other advantage to this one is that when you FreeBSD update it once, it applies to all of your jails.
Yeah, so one for everything. However many you might have.
Yeah, but in general, it's usually a bit more work than it's really worth.
Yeah, as long as they're running and there are no known exploits or anything.
Sometimes
That
you don't want to upgrade all 10 of them at once.
Yeah. Give it some time, one by one.
One of the other interesting things you can do when you want to do an upgrade is you can snapshot the jail, clone it, make the new one, run the upgrade in it, make sure it's all good, and then swap the IP address over or whatever, and
discard the old
then throw away the old one when you're, you can archive the old one for a little while and throw it away later or whatever, so that while you're doing the upgrade, the jail still exists in its working state the whole time.
Yeah, and that's one of the powerful things.
That way.
Yeah, you wish other systems would have that functionality.
And then they show you a couple more tips for simplifying your config when you have a lot of the same things. You can, for example, set the interface that all your jails use and the global part, and then it applies to all of the jails and you don't have to do it manually. And you can also use the templating. So you can use the variable $name for, say, the host name and the path. And that way each jail will automatically be, user local jail / the jail name, or the host name will be jailname.domain.local, and so on. And then you can get almost all of it pre-solved for you. So with that, you literally just set the last octet of the IP for each jail, and it's good to go. Or even, they have their fstab file automatically configured, so the ones that don't want one, set it back to blank. And you end up with a very thin jail config because all your defaults fill in the settings for every jail. So each jail just needs a name and an IP address, and everything else is defaulted but can be overridden.
So, time for the BSD Bits, number 256 edition. We have, of course, by the time you watch this episode, it would be already over. There's a meetup in Zurich, but there will be future ones, one in August. So we thought we mentioned it so that people can look out for it and make
so
plans.
they sent it in almost in time for us to cover it, but we recorded it a week early to cover the fact that Benedict's away starting a week yesterday or something like that. When you watch this, it'll be last week that Benedict was leaving. But anyway, so there was a meetup in Zurich in July on the 19th. If you're watching live, that's tomorrow, and maybe you'll get to go. If you're not watching live, sorry, you missed it. But keep an eye on this mailing list. It's the FreeBSD advocacy mailing list, I think. Yep. And you will get notified in time to go to next month's. But like good people, the BSD Poland people have secretly given us the dates for the next two meetings to tell you ahead of time. So the BSD Poland user group will meet in Warsaw. I think, I imagine it'll be at Gil's offices again in Warsaw there, on July 30th, and then again on August 9th. I know the schedules, that seems a little close together for the two monthly meetings, but I think the July one just ends up being late and the August one ends up being early because of scheduling and holidays and so on. But starting at 1830 Central European Standard Time on, July 30th and August 9th, there will be user group meetups. The website, as of today, still has the stuff from the last meeting, but if you would like to attend, you should click and go. And if you would like to give one of their short 15-minute talks, they would love to hear from you as well.
Oh, yeah. It's good to see those meetups happening all over the world.
And if you're having one, write in and let us know. But we need like 2+ weeks notice in order to get the message out in time for people to actually show up. We're sorry that our recording schedule is a mess, but we both travel way too much.
Yeah.
So, but normally we wouldn't cover an article with a title like Linux Geek, but this is a humble book bundle from No Starch Press, and it actually includes some BSD books and some not Linux specific books. So if you're interested in automating the boring stuff with Python, the Artist's Guide to GIMP, the Art of Debugging with GDB and DDD and Eclipse and so on, or Perl one-liners, 130 programs that get things done, or a book about virtual networking, or a free no-starch sampler that comes with a little bit of a bunch of different books. Or they have books about Inkscape, another book about GIMP, the book of PF for both FreeBSD and OpenBSD, a book about the GNU Make utility, a masterclass in Blender for doing 3D modeling and so on, and doing math with Python. Plus, wicked cool shell scripts, absolute OpenBSD, the Arduino project handbook, and Think Like a Programmer are all available in this bundle. And then depending on how much you pay, you can get additional things, including the Linux programming interface if you really want that.
Yeah, well, it's a good thing because you can decide how much money you want to spend on that bundle, and that goes to a good cause.
The more you spend, the more books you get.
Yeah. But there's more in our... Yeah, good news.
We've been waiting about almost 2 years since I did the BIOS-only implementation. So Ian Lepore has extended the work I originally did for Geli boot support for AMD 64, and now extended it to all architectures. So that means UEFI boot on AMD 64 now supports EFI directly, and you don't have to have the separate boot pool that breaks boot environments. But this also extends it so that you could have a fully encrypted disks booting UFS or ZFS on your Raspberry Pi, or a Pinebook, or MIPS even if you wanted to, but that would be terrible and slow.
But it works.
But yes. So Ian writes that he's extended the loader Geli support to support all architectures and any disk-like devices. So it also works on things other than just what the BIOS would consider a hard drive. This moves the bulk of the Geli support code from the libi386 BIOS disk into a new Geli device file, which implements a device SW type device, which basically gets into the proper layering. So every time you try to do a read, if it's a Geli device, it goes through this extra transform layer before going up and down the stack, a little bit more like Geom and how Geli works on regular disks but at boot time. Where functions handle Geli decryption, support for all arches comes from moving the taste and attach code to the device open function in lib standalone. After opening any disk type device, dev open calls the new function Geli probe and attach, which will attach the Geli code to the file open struct by creating a Geli dev description interface to replace the disk description interface for that open file. So when you open a disk, if it's detected that that disk is Geli, then it will replace the disk interface with the Geli interface. And when you call through the Geli interface, it will then call through into the disk interface for you and decrypt the result as it comes back. So this routes all I/O for the device through the Geli code instead of the terrible, terrible hacks that I did before. This also introduces a new public interface, Geli add key, which allows any architecture or vendor-specific code to add keys obtained from custom hardware or other sources, which I'm hoping soon will support a USB stick stuck in the side of your laptop to auto-load key material out of. With these changes, Geli support will be compiled into all variations of the loader on all architectures because the default is with loader Geli.
Okay.
So this is a big step towards eventually having support for everything.
Very nice. Yeah, that's good to have that polished.
So it's not quite finished. Sorry, there isn't a tutorial on converting your system from, if it's UEFI, from the old way of booting, where you had the two separate pools, to the new way. However, there is this tutorial on converting from FreeBSD 10.3 to FreeBSD 11 when you were BIOS booting, and basically reclaiming that boot pool and getting everything switched over so you can have full boot environments. So if you follow this tutorial, but avoid the steps where you update the GPT ZFS boot, and instead replace your EFI boot file on your that little MS-DOS partition with the new loader.efi after you upgrade with this patch, then you'll be able to convert to a boot environment compatible system. So I will also shortly be making the changes in the installer to do away with this old mode, which will be glorious.
Yes.
So hopefully we'll have a better tutorial in the future on converting your system so that when people upgrade to 12 with this support, they'll be able to quickly get support for boot environments if they didn't have it before. This matters a bit to me because newer laptops that have NVMe devices can only boot EFI because BIOSes don't know about NVMe. And so it meant that the work I did to make this usable by everybody was not usable by people with new laptops. So hopefully that will be fixed soon.
Yeah. Thank you, Ian, for that work. And
Yes.
next up is Package Source 2018 Quarter 2 for Illumos is available with 18,500 and more binary packages. So this is a nice little tweet here from Jonathan Perkins. Is it Jonathan?
Yep.
Yeah. And
it says,
the screenshot here.
Special thanks to the efforts of the NetBSD developers on making package source work on many operating systems.
Yeah, that's certainly valuable to not just NetBSD, but other projects as well. Speaking of NetBSD, we have ARM64 images available with SMP for Raspberry Pi 3, the NanoPi, and Wine64 boards over at NetBSD. That's always good to have recent versions. And what else? Oh, yes, of course. There's a recently released CDE 2.3.0 running on Triplix, which is Illumos. And this is also a little tweet here where we got this status information.
Yep. So Triplix is another distro of Illumos. And they have the old CDE, which I think is the commercial desktop environment.
Yeah, or common desktop environment, something like that.
One of those. It's kind of it was the commercial version so KDE was trying to pretend to be CDE, but free back when Sun sold CDE. But now
so it must be
source
commercial.
And they have it working.
Cool. And next, we have an interview with tech and science fiction author Michael W. Lucas. This is over at YouTube, an interesting interview. And it's not just the books he writes, but also a little bit, around the person.
Yep. So this is from the kind of podcast of the Lawrence Systems or PC Pickup, their computer store type thing, talk about hardware and stuff like that. And so they cornered Michael Lucas and talked to him for 41 minutes.
See, that certainly should have a nice content in that interview. So check that out. And we also want to remind you that there is still a MeetBSD call for papers going on until August, the beginning of August, if I'm not mistaken.
13th.
Yep. So if you haven't submitted yet,
you have until August 12th to submit. The time says 13th, but look, you have 7 in the morning UTC. So if you're in California, that's actually midnight on August 12th. They fudged it by 8 minutes to solve those complainers, but anybody who submits in the last 8 minutes will be publicly shamed at the conference.
Yep, keep track.
From being on the program committee for EuroBSDCon, the graph was like there's a little spike of people doing it right near the beginning, and then nothing, and then the last day is every single person. I think 60 of the 68 submissions came in on the last day.
Be a little spike in the graph for MeetBSD. Submit something now.
Yes. I'd much rather see a nice smooth
increase
rather than this hockey stick nonsense.
That's interesting coming from a
Submit
Canadian.
Early. Submit often. Give us all your ideas and we'll pick the best one.
Yeah, the better the conference will be with the best papers that you submit. But if no one submits anything, it's a difficult choice to fill the conference.
Yeah. We only really need 100 words or so describing what you want to talk about. But the more you tell us, the better chance we'll pick you.
Yep. And speaking of conferences, last but not least, EuroBSDCon talk acceptances have gone out. And once the tutorials are confirmed, I just clicked the confirm button last night. Registration will open. That will likely happen.
Yeah.
By
the time you're watching this, that probably has already happened. So head over to eurobsdcon.org and register for the conference. And we'll see you in Romania, September 20th to 23rd.
Yeah, it'll be great to have you there, especially if you don't go to the BSD cons regularly or only to certain ones that are in your area, and Romania should be one that should be affordable by most people.
Mm-hmm.
So we look forward to it. We'll both be there, and yeah, say hi if you see us in the hallway or wherever we are.
Yep.
So before we go into the feedback and questions section, we should cover our sponsor for that one, which is the Tarsnap Backup Systems, which is providing you with online backups for the truly paranoid. Head over to tarsnap.com to see that, what it offers. And what it does is creates backup into the cloud. But then you say, wait a minute, isn't that unencrypted? No, it's not. It's encrypted, but it's encrypted on your box before it goes into anywhere that's internet or cloud-like. And since you're the person holding the keys and don't give them away, you are the only one who can decrypt those backups in case you need them. So Tarsnap will take your data, will do segmentation and deduplication of the blocks with a little hashing algorithm. And once that's done, it compresses those blocks, encrypts and signs them, and then it will push those out into the AWS, where it sits with other backups, nice and easy, but no one can figure out what's in the backups because it's all mumbo jumbo.
The key that was used is only on your computer, and as long as you keep it secret and don't lose it, the only person that will be able to read the backups are you. If you lose it, no one will be able to read your backups, which is on purpose, because if you want to delete the backups, you can never be sure that Amazon actually got rid of all the backups of your backups and so on. Whereas, if you destroy the key, then nobody can ever decrypt it, ever.
Yep. But then you can also get your backups back, which is the actual case in case you get disaster strikes and you want your files back. As long as you have the key, Tarsnap will download them back for you and you can continue where you were. So head over to Tarsnap, check out what they have in offer. They have a bunch of documentation, how to get started, clients for your operating system that you might run because they run on a bunch of operating systems, and how to get started, create an account, and then go from there. So feedback and questions we got.
If you talk to someone at Tarsnap, make sure you tell them that you heard about it here.
Oh, yes, of course. That's the show reference is important. Yeah. So the feedback and questions section for this week, some people reacted to our call for more feedback and questions and send us stuff. Thank you for that. But again, don't stop sending stuff if you are in need of questions being answered. So first one is about ad blocked on FreeBSD continued. Oh, that seems like something we've covered already, but it's a continuation. So that goes, Dear Alan and Benedict, thanks for your great show. I have been listening for over a year now. Oh, great. You previously mentioned my ad blocking projects that I shared with you on the show, which is inspired by Pi-hole. I have now created a statistics graphing web app as well as the background service in Perl and Modulicious Light. I would be interested in contributions from the community to extend and improve it. I have tried to keep things as simple as possible, and the whole project consists of 3 Perl files and only a handful of dependencies already in the port stream. Wow. It currently gathers statistics for my customers using my ad blocking app for Samsung phones, and the web server sits behind Nginx on a FreeBSD Digitalocean droplet here. So there's a link. There's OpenS3.net. And the project is BSD licensed, excellent, and available on GitHub. There's a GitHub link in our show notes. For contributors, I don't know if other people would find it useful enough to create a port, but if you want the core features of Pi-hole but want to still run BSDs, this can help. Cheers. Hey, wow, that's a great project and a continuation to see having graphing now.
Yeah, I think a port might be useful.
Yeah, you never know who uses that or has exactly that same problem and wants to use the same functionality but don't want to code it themselves, and then just package install or make install from the ports directory, and then they have it. Cool, thanks, and continue to work. Hopefully some people, if you're interested in this work, head over to their website that we have in the show notes or send it to us at feedback@bsdnow.tv and we'll link the two together. Okay, next up is Andrew with a question and a story. That goes, Hi Alan and Benedict. Question, RAID Z expansion. Alan is listening. BSD CAN videos aren't out yet. Can you give us an update on Matt Aaron's work on RAID Z expansion and your thoughts on whether it will make it in time for FreeBSD 12? Yeah, so that got a little...
12, no. sadly.
It's too late.
It'll be 12.1 or something. It's probably not going to be ready till closer to the end of the year, and the feature freeze for 12 is in like 3 or 4 weeks.
Yeah, and Matt Aarons is good, but he's not that good because also the code needs some, more eyes to look at and some fleshing out, some more testing. So we'd rather wait a little bit longer to have a good working RAID-Z expansion once it's available. So
yeah,
I know
probably not for 12, but the good news is that actually means it is very likely to land in 11.3, which will probably come up before 12.1.
Yeah, so that's a little ray of light.
As soon as it's available, we will get it to you, but you're going to want to wait until it's, working.
And we'll be sure to mention it on the show because we're looking for it ourselves.
I will go and buy some balloons for that one.
Oh, yeah. Yeah, great. Okay, so the story about how I got into BSD and the impact this show has had on my life. Oh, wow. Here we go. Good or bad? Yeah, so we'll see. A new episode, a few episodes ago, you spoke about how FreeNAS was definitely a path into FreeBSD. It was one step on my path. Many years ago, I watched building a NAS video with a Wendell. You've had on the show, yeah, we did. When he was in his previous channel. That got me into FreeNAS, which led me to the show. And now I run FreeBSD on my home server. See, we kind of have an influence on certain decisions. But that's just the tip of the iceberg. Due to injury, I was forced to quit my physical job a few years ago and head back to school without any clue what to pursue. Oh, wow, that's a life change here. It was this show and the work done by yourselves and many fantastic guests that inspired me to choose computer science, something I didn't think I was smart enough for. I'm doing great. I even chose the university to study at because that's where your guest from episode 106 was doing his master's work. And I thought, wow, they do something interesting there and they must care about open source. So FreeNAS made me aware of BSD. It was the bait, but this show is what hooked me and made me truly want to be involved. Excellent. I hope one day I'll gain the skills and or even a job that makes me able to give back to the project and its community. Yeah, why not? You might never know how many companies are listening there who are in need for skilled computer scientists once you're finished. So thank you, Alan, Benedict, Chris, if you're listening, and all the people working behind the scenes for having such a positive impact on my life. This story may be a little long, and I don't mind if it's omitted from the show. No, we won't cut anything out of that. I just wanted to thank you all. Oh, wow, that's a great feedback. That's certainly. I mean, I know injury it can be difficult if you cannot work in your previous job anymore and have to you think your life and align you into a different direction. But wow, isn't that a great outcome so far? Wow, excellent. Yeah, so. Continue studying, keep interested in the BSDs, and especially in computer science, you definitely will find enough references to, with that background, you will definitely do good. So yeah, good luck with that, and yeah, send us something more if you found an employment in this area with BSD. We'll be happy to hear that.
Yeah, I'm glad we were able to help you.
Can it even get better than that?
So you're going to university in Australia? That's cool.
Yeah. Very nice. So Matthew is next with thanks. Okay. Yes, keep them coming. Yeah, it's episode 256 anyway, so it's definitely worth it. So that goes. I wanted to thank you guys for the show every week. I don't have yet a BSD system, but will soon when my new motherboard arrives. Not sure if it's going to be Ghost BSD or TrueOS is the way, but one or the other will it be. I have been listening for a year and just set up a ZFS mirror pair of disks on my Linux box. It's been a great fun listening and applying the info you all have been sharing. And I did install FreeBSD years ago, 2000-ish, whatever. But at the time, I was living out of the country. We had cows. Oh, cool. And had a crappy software modem. Oh, I can see. Yeah. So I couldn't use BSD at the time. Thanks again, Matt.
I think that was the main reason why I didn't get into Kernel Linux early on.
Oh, because of the...
Because my modem, I couldn't make it connect to the internet. So it made it very hard to seek help on how to do things.
Yeah, it's like...
But luckily what I ended up doing was accessing a remote FreeBSD machine from my Windows desktop and learning about BSD.
Mm. And yeah, you never know when you get into BSD. It's never too late, actually, to start. But it's certainly good to start early, but it's not the end of the world if you miss a couple of years. So yeah, definitely good feedback as well. And yeah, continue. If you have any interesting stories in the distributions that you finally chose once your motherboard is here, then yeah, send that to us as a follow-up or maybe a little blog post that we could cover on the main show. Why not? So last but not least is Brian with a PCIe controller question. Dear Alan and Benedict, I'm working on a home NAS and wish to set up my system with a stripe of mirrors. The config
Nice
would be yeah, good choice. The config would be a stripe across two sets of mirror drives. My motherboard has only 4 SATA ports at 3 gigabits per second. Yeah.
Mm-hmm.
I have an old SATA PCIe controller. However, it runs at 1.5 gigabits per second. I like the idea of using the zpool replace command while all the drives are online to upgrade from 500 gigs to 1 terabyte drives. Yes. I thought that on a previous episode it was said that drives are not bound to the SATA port they are initially connected to. It is possible to use the slower controller only for drive replacement. Once the new drive is in, or it has the data on the drive it's replacing, then the drive can be connected to the faster port and the old drive is removed.
Yes. ZF has put its own label, 4 copies, 2 at the front and 2 at the back of every disk. So it figures out where the disk is no matter what the device name's changed to. So you can randomly plug the SATA cables in differently every reboot and it'll be fine. So yes, with spinning hard drives, you're probably not even going to run into the 1.5 gigabit limit versus the 3 gigabit one. But yes, you can have your 500 gig drives running off your 3 gigabit ports, hook up the card and install your new drives on the 1.5 gigabit ports. Do zpool replace on all 4 drives at once if you want. Once it's done resilvering, which will take less time because it'll resilver. During the resilver, it scans every block and it can write to 4 drives and read from 4 drives instead of 1 drive at a time. Once all that's done, then you can just shut down, rewire everything. You could probably even remove the 1.5 gigabit card from the machine if you don't need it anymore, and you'll be done. Your other option is to use the 1.5 gigabit card and add the now unused 500 gigabit drives back to the pool as additional storage. Although drives that old, you're probably worried they're going to fail or something, but you could add another stripe that way. Or you could even decide to take all 4 of the 500 gig drives and make one 4 drive deep mirror. So one mirror that's just all 4 500 gig drives, and add that. So even as they fail, as long as any one of the 4 keeps working, you get that extra 500 gigs of usable space. Because while the drives in the same VDEV have to be the same, when you're adding an extra VDEV, they don't have to be the same size.
Yep. And if you do zpool status, you will see those internal labels because some of them will say was dev whatever ID.
Right. That's just a hint. The actual label is the GUID. If you do ZDB-L and then the device name, it'll print out the 4 copies of the labels and you'll see it knows about all of its siblings. It knows it knows all of its siblings and it knows how many VDEVs there are in total, but it doesn't know about the ones it's not a member of, so that the pool will work no matter what. Anyway, each VDEV has a globally unique ID, and then each member has it. And ZFS will find your disk as long as it's connected to the computer. It doesn't care if it changes from ADA 0 to ADA 7, or even if it becomes DA 7. If you connect it over USB or something, or switch to a SAS card or whatever.
Yep. And that pretty much wraps up our feedback and questions and the actual show. Again, if you found something interesting BSD related, don't hesitate to send it to us for future episodes. And the email address is feedback@bsdnow.tv. So that has been episode 2 to the power of 8. And we hope to have pretty much the same number from here on to the next iteration of that. So yeah, thanks for listening all the time and keeping with the show. keep sending us feedback, good or bad. And of course, we couldn't have produced the show if we didn't get any BSD news. So also thanks to the BSDs out there, big and small, for doing the work each week and giving us something to report. Have a good week and see you next time.